Alright, we're going to refresh on our fractions before we do this bad boy. Now, normally this one right here is just multiplying, but I changed it to division to get one more step in there. Because sometimes you do encounter division problems with rational expressions. Okay, let's go back into time, way back. Alright, here we go. We got, let's say we got a 2 over 3, and then we have a dividing, and then there's a, what do you say? Let's do a 4 over 15. Alright, whenever you divide fractions, you guys know what you used to do? Yeah, multiply by the reciprocal. So, why don't you guys show your neighbors what that looks like? Ready, set, go. This is what it looks like. You get 2 over 3, and you change it to a multiplication, and then you put the 15 on top, the 4 on the bottom. Notice we only flip one of the fractions. We flip the second one. Okay, the next thing you learned how to do when you guys learned how to do fractions, you learned how to simplify it, called cross-canceling. I'm going to simplify using factoring. You guys didn't do this before. You would have just looked at it and said, hey, I can divide 15 and 3 by 3. And if you could divide them by the same thing, then you would simplify the numbers. I'm going to do it by factoring, though, because that's how we do it with these big bad boys right here. So we got 2 over 3, and those are already factored. I cannot factor those anymore. 2 and 3 are already factored. Now I have 15, which I can factor. I can write 3 times 5. I can factor 4, too. I can factor that to be 2 times 2. Now, before I multiply, one trick is to cross-cancel. You can divide 2 and 2 by the same number, and so you would get 1 for each of these. You can also divide these 3's. Now, students, unfortunately, forget why they are allowed to cross these 3's out. They just think, oh, if you have one on top and one on bottom, you can cross them out. Well, pretty much that rule does work, but why? You can do that because you can divide them by the same number. Alright, so then I have 1 times 5, which equals? 5. And then I have 1 times 2, which equals?
2.
So that's my final answer. So that's how you would do this division problem. You change it into multiplication and then simplify where you can and finally multiply to get your answer. Alright, so we got lots to factor here. That dude's ugly, that dude's not that bad, that dude's not that bad, and this dude's not that bad. So let's save the ugly guy for last, shall we? We shall. Alright, so first thing we're going to do is we're going to rewrite everything so that we are multiplication. So first I'm going to rewrite it. So I have 2x squared plus x minus 6, x squared plus 4x minus 5. And I'm rewriting it because I'm trying to be explicit and make sure everybody can keep up with me. Now I'm going to write x to the third minus 3x squared plus 2x on top. On the bottom we have 4x squared minus 6x. So what happened? The second fraction got flipped because we are multiplying now. Now I need to factor all these dudes. Alright, let's do our denominators first. Okay, so the first denominator, when I factor that one, that's a regular trinomial. The leading coefficient is a 1, so you get to just think about it. I mean, most of the time you can do this in your head. We have what times what gives me negative 5 and then adds to 4. Now, if you're a person that doesn't do math very well in your head, you'd probably write this out. You would write negative 5 up here, and then you write a 4 right here, and you think to yourself, what times what gives me negative 5, but then adds to give me 4. And you say to yourself, well, self, if I go negative 1 times positive 5, that will give me a negative 5 and then add to give me positive 4. And then you get all excited and you factor it. So you get x minus 1 and x plus 5. Alright, that one's factored, done. Now let's do our next denominator. Our next denominator is not a trinomial. So because it's not a trinomial, I'm not going to factor this your traditional way. I'm going to factor this using a greatest common factor. What can I take out? What can I divide both of these terms by?
2x.
2x. And so I'm going to take a 2x out so that it looks like this. I put a 2x right there. I put parentheses around it because I want it to look like the other factors. 4x squared divided by 2x is going to be 2x, and then I divide the 6x by 2x to get 3. Yay. Alright, now the top comes along. The top, I noticed something right away. I can divide each of these terms by x. So the first thing I'm going to do is I'm going to take an x out. Alright, now I'm going to need a little bit more space here, so I'm going to color over this guy right here with white. And then I'm going to take an x out. I'm going to take an x out and then write what I get. I get x squared minus 3x plus 2. Yay! That's a simple factoring trinomial problem. The leading coefficient is 1. It's just like this guy down here. So what times what gives me 2, but then adds to give me negative 3? Don't think too hard. We have x. And then we're going to have 2 factors. All right, let's write it out. Big X. I'm going to put a 2 up top and a negative 3 on bottom. I'm thinking to myself, what times what gives me 2? And I thought, oh, 1 and 2. But when I add this 1 and 2 together, do I get a negative 3? Not dag. So I have to have a negative 1 and a negative 2. If I add negative 1 and negative 2, do I get a negative 3? Yes. For sure, diggity doggies. So I'm going to write x minus 1, x minus 2. All right, almost everything is factored except for this bad mamma jamma right here. Now, I think that you guys learn how to do this with the box. So I'm going to show you guys with the box. That leading coefficient is not equal to positive 1, so that's going to require some work from us. Now, if you're using the box, this is how you use it. You go like this. You make a little box like this, and then you plug in the terms. I'm going to plug in 2x squared right there, and then I'm going to plug in negative 6 right there. Then I have this 1x right in the middle. That 1x goes right here. I know, it's all the way down at the bottom of the screen. I hope you guys can see it. So I have the 1x term down there at the bottom. I have these two guys at the side. All right, my answer, my factored form, is going to be the numbers or the terms that are on the outsides right here. So I have to find out what times what gives me 2x squared. 2x and x. 2x times x gives me 2x squared. Yeah. Now the other two numbers, the other two terms, this one and this one that I have to pick, have to be very specific. They have to add to give me 1x after I multiply it out. So, how do I find those numbers? There's a fast way to do it. Now, since this is not a factoring lesson, I can pull out some tricks that I know that I've learned. I'm going to use the big X, but this big X is going to be different. Instead of putting negative 6 on top, I got to put negative 6 times 2 on top, so I get a negative 12. This one, when I made the big X for this trinomial, I just put a negative 5 up there because the leading coefficient is positive 1, and positive 1 times negative 5 is negative 5. But here I have a 2. 2 times negative 6 is negative 12. So now, on the bottom, I put a 1 because of that x right there, the 1x. What times what gives me negative 12, but then adds to give me 1? 4 and 3 add to give, or multiply to give me positive 12, but one of those has to be negative. Which one's negative?
3.
The 3 is negative. Why is the 3 negative? The 3 is negative because when I add them together, I need to get a positive 1. If it was a negative 1, then the 4 would be negative. All right, so now I have a 4 and a negative 3. You know where you put those? I'll tell you where you put those. You put them in these squares right there. But which one goes where? Does it matter? Huh. Let's try it. Let's put a negative 3x right here and then a 4x right here. Okay, can I take a 2x out of 2x squared and negative 3x? No. Oh, so we have a problem. Let's switch the numbers around. Let's put 4x right here and negative 3x right here. Now, I chose to switch those numbers. I could have switched these ones. But anyways, let's see if it works now. Can I take a 2x out of that one? And can I take a 2x out of that one? Yeah. All right. What can I take out of the negative 3x and the negative 6? Ooh, a 3. But you want to make that one negative. You know why? You want to make that one negative because both of these are negative. So that's a negative 3. What can I take out of a negative 6 and a 4x? A dose. Very nice. Now we got our answer, I think. Let's check it. 2x times x is 2x squared. 2x times 2 is 4x. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. And negative 3x plus 4 is 1x. Cool. We got our answer. So we write 2x minus 3. And then we have x plus 2. All right. Now it's time to kill some factors. All right. You see over here, remember how we... Oh, I erased it. Remember how we crossed out similar factors? If there's a similar factor on the top as on the bottom, then we get to kill them. You guys ready to kill factors? Yes, let's kill. All right. Let's see. Which one can we kill?
2x minus 3.
Ah! Ah! They're dead. All right. We got any more? X minus 1. All right. Ouchie! Ah! And then, any more? There's one more in there. Don't let him get away. the x's. You see these x's? Get them. S. Oh.
What X's?
All right. Now you just multiply straight across to get your final answer. Multiply, I shall. Oh, yes. Someone said I thought I was dividing. Remember what we did when we saw division? We changed it to addition, and then we flipped the second fraction. Oh, snappity waggity daggity. On the top, I get x plus 2 and x minus 2. Those are the only factors left up there. On the bottom, I have a 2, and I have an x plus 5. Now, this answer is correct, but we also need to make sure we always write down what x cannot equal. All right, so what can x not equal? We got to go to our original problem, all the way back to where we started, and we look at the denominators. Look at this denominator right here. You see that denominator?
Yes.
What are the factors of that denominator? Shebang. Right here, right?
Yeah.
Okay, what x values would make these factors 0?
-5.
For this one, oh yeah, for this one right here, if I plug a -5 in that one, that would make it 0, right? And then it doesn't matter if I plug a -5 in over here, I have to multiply it times 0 and make it 0. So -5 is a value that x cannot be. What else can x not be when I look at this factor? A 1. Because 1 minus 1 would be 0, so it can't be 1. All right, now I have this other one right here. You see this factor right here? Or these this polynomial? Is this one written in factored form anywhere for us? Shebang-a-dang, right there. You guys see that? It's already written in factored form. Okay, look at this first factor. What value of x would make that factor 0?
0.
0. So it can't be 0. What value of x would make that factor 0? Uno. Oh, we already got uno. Okay, so what value of x would make that factor 0?
2.
Dos. All right, there's your restrictions.